Question 15 here. Which statement about the evaporation of the liquid is correct? Evaporation. The least energetic molecules escape? No. The least? No. Okay, the most energetic molecules escape from the surface and the temperature of the liquid decreases? Yes, yes. The most energetic molecules escape from the surface and the liquid of the, no. So the answer, it will be what? C. Yes, thank you, Saif and Muhammad and Hazan. The answer is what? Is C. Okay? It's obvious, it's clear. You can see that some of the questions we can answer in less than 20 seconds as we read the question. Question 16. A bubble of gas is formed in a deep underwater. Okay, the bubble has a volume of 40 centimeter cube and the pressure inside the bubble is what? P. Now we know that the pressure inside and outside, they have to be equal, so the size of the bubble remains the same. Okay, so this is V1 and this is P1. Okay, why I use this one? Because they will ask about the change in pressure or the change in volume. Look here. The bubble rises up on the through the water. The volume of the bubble increase to how much becomes V2. This is what? 56 centimeter cube. Okay, cubic centimeter. And the pressure becomes how much? 100,000 what? Pascal. This is what? P2. Okay. The temperature of the gas does not change. This is the assumption that we have to know how to use it. Okay, since we are going to use the formula P1 V1 equal P2 V2. What is the initial pressure? So they ask about P1, which is P, multiplied by V1, which is 40, equal P2, which is 100 kilopascal. The units are kilopascal and pascal. So here another 3 zeros. Multiplied by what? V2, which is what? 56. Okay, divide by 40, divide by 40. The answer P equal how much? Equal 140,000 Pascal. So that means the answer is 140 kilopascal. Okay? Right? Yeah. We have to be careful. We have kilopascal here. There's kilo. Okay, we have to add another 3 zeros. Okay, if you didn't add the 3 zeros, the answer it will be 140 kilopascal. Yes. You have to be careful, okay? Tamam, good. Okay, next. Number 17. Which change in the design of the liquid thermometer, okay, liquid and glass thermometer makes more sensitive? Now, when we talk about more sensitive, we have some certain ideas to get the liquid and glass thermometer to be more sensitive. Larger liquid reservoir, yes, it will be more sensitive. Longer tube, it's not necessarily. Smaller liquid reservoir, no, it's not necessarily. Wider tube, no, it will not be sensitive, okay, for sure. Okay, so which one is the answer? Yes, the answer is what? Is A. Good. So this and this are opposite, okay? So the answer is larger, not smaller. Okay. Next, question 18. A liquid turns into a gas, okay? This occurs only at one particular what temperature, and the change happens throughout the liquid, throughout the whole water, throughout the liquid. What this called? It's not evaporation, because the evaporation happens at not a particular temperature, at any what temperature, okay? And it does condensation, of course. It's not fusion, it's boiling, yes. Good. Number 19. One end of a rod of copper is placed in hot water. Thermal energy travel along the rod to make the other end warmer, okay? A copper rod here, okay? What is the behavior of the copper, okay, at the atomic level, okay? And that accounts, for most of the transfer of the thermal energy from one end to the other, okay? The atoms, okay, at the hot end gain energy and move towards, no, they don't move. This is not correct because it's solid, okay? Atoms of hot, okay, expand, do the atoms expand? Okay, no. Okay, colliding with what? With other atoms and transfer energy? No. if they, if I say vibrate more or increase their kinetic energy, yes, correct. Thank you, Muhammad and Mariam, for the answer. Yes. C, free electrons at the hot end gain energy and move towards what the other end, colliding with what atoms, okay, along the road, along the way where they have it. Yes, this is, I think this is the correct answer. Okay, free electrons at the hot end gain energy from the hot water and move directly to the other end. Directly, not necessarily. So the answer is what? C. No. Now look here. Let's compare the last two statements here. Okay, free electrons at the hot end, free electrons at the hot end, gain energy, gain energy. Okay, and move towards the other end. Okay, from the hot water. Okay, do they move from the hot water or from the same road? Okay, so move towards the other end, colliding with what? With the atoms along the way with the move. Yes, this is correct. Okay, and not electrons from the hot water, they move through the object. Okay, so the answer is C. Okay, number 20. A surface is made so that it is a good source of infrared radiation. Okay, infrared radiation. Which surface is not suitable? Okay, a surface is made so that it's a good source of infrared radiation. Which source is not suitable? Okay, a surface that's painted with matte black, a surface painted white, a surface that heated to a high temperature, a surface that has a large surface area. Now we know that whenever we need to make it a better infrared radiation, we need to make it dull black or matte black, not white. Okay, we have to make it high temperature as possible, and whenever it's larger, it will emit more radiation than whenever it's smaller. So the answer, yes, thank you, Muhammad and Mariam and other Muhammad. Okay, we have two Muhammad here, and Hazin, yes, thank you, all of you. So the answer is what? Is 20. Okay, thank you, sir. Yes, thank you. The answer is B for question number 20. Next. Now, what do we have here? A large hill blocks, okay, at a direct path between a transmitter radio, okay, of radio waves and the receiver as shown. Here we have transmitter, we have a hill, we have a receiver here. The receiver pick up the signal from what the transmitter even though the radio waves do not travel through the hill. Which row is correct? Now we know that the radio waves, they don't curve. They don't curve. They keep moving in a straight line, right? But what they do here, as they move, what they do, okay, I'm talking about radio waves. That means they have very long wavelength, okay? For example, this is the wavelength. What they do? Exactly, they diffract, okay? So a possible way for what's happening here, diffraction, not refraction, A strong signal received that has what? Radio signals that is longer. Whenever it's longer, the diffraction will be what? Greater, not the short. So which one is the answer? Yes, thank you. The answer is A. This is question number 21. Okay, number 22. What do we have here? Okay, and number 22, the diagram shows the image of a clock in a plane mirror. Okay, plane mirror, that means it's reflected. Which is the actual time? What is the actual time? Now we can see that the reflection here, okay, make what? Instead of having the short arm in this position, it will be what? It will be positioned somewhere here after 7. And instead of making the long arm, okay, in this position, okay, at 45 minutes, it will be in the other side at what? 15 minutes. So what will be the time? It will be 7 and 15. So the answer is what? The answer is C, right? Good. Do you want me to repeat it for you? Okay, I'll repeat it for you. Now, what do we have here? We have, okay, a mirror. So I will what? It's laterally inverted. I will make reflection of these arms. The long arm, instead of being to the left, it will be to the right. And the one, okay, in shorthand, okay, it's instead of being between 4 and 5, it will be between 7 and 8, somewhere here. So it will look like this. This is how the watch will looks like. Okay, the real one. So the time, the actual time, it's 7 what? 7:15. Good. Any questions so far? Okay. Next, number 23. What do we have here? A converging lens processes an image of an object O. The focal length of the lens is f, small f, okay, which is the position of the object produce a virtual image. Now we have for converging lens as we study 6 different cases, okay? The first 4 cases are what real image. The 5th case we have virtual and no image, and the 6th case it's what virtual image. And the 6th case we say that a distance object farther than 2f at 2f, between f and 2f, at f, before f, or closer than f, closer than the focal length. So the answer for the object to be between the lens and the focus point. So the answer is what? A. Yes, thank you, Muhammad and Sarah. Yes, in this situation we have a magnifying object, okay, real one. Okay, in this situation we have a same size real object. Here we have a smaller size object which is real, okay, image, sorry, which is real. So the answer is what? Is A. Okay. Number 20, what? 24. The diagram shows the electromagnetic spectrum: gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, radio waves. Increasing something. As we go to the right, we will increase something. Now we know that here we have the highest what for gamma. We know that we have the highest what frequency, and the radio waves has longest what wavelength. So which one will be the answer? The word is missing. When we go to the right, exactly, they have D, the longest wavelength. All of them in vacuum, they have the same speed, okay? They have the same speed. The amplitude depends on the source, and the frequency, whenever we go to the left, it will increase, not to the right, okay? Tamam? Okay, this 24, question number 24. Question number 25. Which row gives what? A possible set of values, okay, for the speed of sound: ice, water, steam, solid, liquid, gas. For ice, it's supposed to be high speed, solid, okay. For water, it's supposed to be an average speed, something like this, okay, and 1000, 1000 something, okay, and steam is supposed to be a low speed. So the answer, exactly, it's D, it's obvious, okay. They keep repeating the same question. Okay. Question number 26. A steel bar is placed at an east-west direction. Hold on.